With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
The question states, a solenoid having inductance 4 Henry and resistance 10 ohms is connected to a 4-volt battery at t is equal to 0. Find, first part is the time constant, second part is the time elapsed before the current reached 0.63 of its steady state value, and third part is the power delivered by the battery at this instant and the power dissipated in Joule heating at this instant. Okay, so let's begin. So first of all, let's write down the things that have been given to us. Number one, that is L, that is inductance is given to be 4 Henry, and we have resistance, that is 10 ohms, right? And then we have EMF of the cell, that is 4 volts. Okay, now let's consider the first part. First part is in which we have to find the time constant. What is time constant? That is tau. And we know time constant tau is equal to L by R. That is inductance divided by resistance. Inductance is 4 and resistance is 10. So we conclude from this time constant is equal to 0.4 seconds. That completes our first part. Now let's take the second part. The time elapsed before the current reached 0.63 of its steady state value. We must be familiar with this equation, and that is I is equal to I naught 1 minus e to the power minus t by tau. In this equation, I naught is the steady state value of the current. So the time elapsed before the current, so this current reached 0.63 of its steady state value. That means I is equal to 0.63 of its steady state value, that is I naught. So instead of I, we can write 0.63 I naught. So let's write it. So it implies 0.63 I naught is equal to I naught into 1 minus e to the power minus t. This t we have to find, and then we have tau, that is 0.4. We already calculated it. So from this and this, they cancel out. We can write it as e to the power minus t by 0.4 is equal to 1 minus 0.63, right? So this is equal to 0.37. Here we have e to the power minus t by 0.4. Okay. So from here, taking ln on both sides, e and ln they cancel out, so we're left with 1 minus t by 0.4 is equal to ln of 0.37. Ln of 0.37 is minus, so we can write it as minus t by 0.4 is equal to minus 0.9942. Minus and minus they cancel out, so t is equal to this into this, and the value we get is again 0.397, which is approximately equivalent to 0.4 seconds. Okay, so this is the time elapsed before the current reaches 0.63 of its steady state value. That completes the second part. Now let's take the third part. The power delivered by the battery at this instant. So we need to calculate power now. Okay, for power we need voltage and current because P is equal to V into I. For that we need to calculate, V is given, that is 4 volts, and now we need to calculate I. So for C part, I is equal to, again using the same equation, I naught 1 minus e to the power minus t by tau. We need to calculate I this time. Okay, I is equal to, what is steady state current? It's like EMF of the circuit divided by EMF of the battery divided by resistance, because that is the steady state value of the current. So we can write instead of I naught E by R, okay, and 1 minus e to the power minus t, and instead of t we can write minus 0.4 because that's what we calculated right here, and instead of tau we can write again 0.4. This and this they cancel, and then I is equal to This E and this E, they are different. This is the voltage and this is the exponential factor. So E is here voltage and that is 4 volts, right? 4 divided by resistance is 10. 1 minus e to the power minus 1. Okay, from here we get I is equal to 2 by 5, 1 minus 1 by e. Okay, after solving this, we'll get I is equal to 0.2528 amperes. Okay, now we need to calculate power. Okay, for power we have P is equal to V into I, that is voltage into current. Voltage is 4 and current we just calculated, that is 0.2528, and this value comes out to be 1.01 watts, which is approximately equivalent to 1. Okay, now let's calculate the fourth part. What is fourth part? The power dissipated in Joule heating at this instant. So the power dissipated will be the heat, right? So D part is P is equal to I square R, because the power that will be dissipated will result in the Joule heating. That's why we write P is equal to I square R. So we can write it here. I square is 0.25, this thing, 28 square into R is 10. And calculating this, we'll get 0.639 watts. Okay, this is the power. So we calculated all the four parts. This is the third part, this being the second part, and this is the fourth part. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.